Also in the area of SolidWorks plastics, symmetry is a big deal. Symmetry allows us to not have to take what is essentially redundant and simulate it all. So here in plastics, we also do symmetrical mold cavities. We have the ability to simulate a part with a single sprue and a runner, and then just by simply determining the star shape or the layout, in this case happens to be 3 in a star pattern, we would get full results but not have to sit through the full simulation of what the total geometry is determined by what we see here. Venting analysis is what allows us to action properly when we find things like air traps, weld lines also, but air traps about venting. This gives us some capabilities to send that air in a particular place, or really just some advice on how we want to tackle the venting of that particular trapped situation. Nominal wall thickness advisor with plastics is really important, because as anybody who does plastics knows, anytime you have dissimilar wall thicknesses, you're going to have dissimilar cooling rates, especially when there's a very thick area. You tend to get sink marks or warpage as a result of that. So nominal wall thickness advisor really allows us to define and design our part more appropriately for plastics usage, not just create an arbitrary piece of geometry and see if it'll fill. So really a great little technology there. And then the mesh improvements. If you see the picture we have over here to the right, those are brick elements. And brick elements, really before SolidWorks, were kind of the dawn of how simulation would be. Now the problem with the brick is that they're more prismatic, which means they're more susceptible to work well with prismatic geometry. So as we got more stylized and CAD products were more capable, we really needed to do something different, which is what we did with our simulation using parabolic tetrahedrons. Well, now these brick elements are resurging, and essentially they're doing that because we're doing something called a non-orthogonal voxel mesh, which allows us to use the brick, but we can change it to more parabolic or trapezoidal types of shapes. Essentially, that allows us to use this nice high-quality element, but in parts that are stylized, that have fillets, very thin regions, or curvatures that just need to have more quality based on a more stylized element, and not be relegated to a quality reduction because it had to be some rectangular or square type of a brick. So it's the best of both worlds when it comes to the brick elements and how they can really tailor themselves more to organic geometry.